Yeah.
To your YouTube channel.
You're subscribed to my YouTube channel?
Yeah.
Awesome. Thank you. That's all right.
Yeah, I didn't know.
All these videos get posted to my, I mean, if you want to call it a YouTube channel, it's not like I'm up there doing vlogs and stuff, okay? Don't be expecting that. It's always just going to be my hands doing math, so nothing special. And they all get linked to Google Classroom, so you don't have to. But I appreciate that, Jordan. Thank you. So quotient rule. Again, all we're doing is subtracting our exponent downward, right? Subtracting downward, which means our top exponent minus our bottom exponent, right? So if we have 4 to the third over 4 squared, this is just going to equal our same base with our exponents subtracted. 3 minus 2. Bless you.
Thank you.
4 to the power of 3 minus 2 gives us 4 to the power of 1, which is just equal to what, everybody? 4, thank you. I think that was Theo, thank you. 4 to the first is just 4, right? Number 2, 7 to the third over 7 to the third. We can go ahead and do our quotient rule here, but we'll talk about a shortcut in a second. So 7 to the 3 minus 3 gives us 7 to the what power?
0.
To the 0th power, right? So I can just leave it like that? 7 with no exponent? No? Why is that wrong, Theo?
Because 7 to the 0th power will equal 1.
Oh, okay. So if I don't put a 0 here, it equals 7 is what you're saying.
Yeah.
Oh, okay. So we got to write 0. And then Theo says anything to the power of 0 is equal to 1, which is exactly right.
Oh my God.
Now forget these steps for just a second and look at our original problem. If I told you to solve this, 7 over 7, what would you say that fraction is equivalent to?
1.
1. Why would you say that?
Because it's full.
Because it's what now, Jordan?
It's full.
It's a full fraction. Okay, so we have the same thing on the top and bottom. Whenever we have the same thing on the top and bottom, is it always going to equal 1?
Yes.
Yeah, right? Whenever we have the same numerator as denominator, this is always going to be equal to 1, right? Do we have the same numerator and denominator in our original question? Yeah, it's 7 to the third over 7 to the third. So without even knowing the quotient rule, we can say, oh, same thing on top and bottom, that's equal to 1, right? Questions on 1 and 2 so far? Awesome. And as I was checking your guys' work yesterday, you guys were really killing it, so I'm not worried. So this 2 on the bottom, is that a 0 exponent? Because there is no exponent, so that's 3 minus 0, right? No? Oh, did I make that mistake again? That's right, it's supposed to be 1. So if you don't see an exponent, make sure you write in that 1 so you don't forget. Because you will forget, I guarantee it. 2 to the 3 minus 1 gives us 2 squared. We can leave our answer like that. Or if you want to evaluate it, you can. That's just equal to 4. But you don't have to go that far. I'm fine with 2 squared. For number 4, we got 5 squared over 5 to the third. So now we got something a little different. We've got a bigger quantity on the bottom than we have on the top, right? We got 3 5s down low, 2 5s up top. So we're going to do exactly what we do before. The numerator exponent minus the denominator exponent, 2 minus 3. And that gives us what? 5 to the power of? Very close with 1.
Negative 1.
It's going to be negative 1. If you start with 2 and take away 3, now you're in the negatives, right? And if you look up at the directions, it says convert all negative exponents to positive exponents in your answer using what we learned in 2.1a. So don't just make this 1 a positive 1 and leave it. That's not what I mean. I mean we got to put this fraction over 1, flip it around, and make our exponent positive. Just like that. So if you stop at 5 to the negative first power on the test, that's only going to be partial credit. because if you stop here and don't take it a step further, that shows me that you don't remember 2.1a. Okay, so we got to make sure that we're building on all of our topics as we go, and not just learning it, doing the worksheet, and forgetting about it. All right, number 5, 8 over 8 to the 4th. Let's do this a different way. Let's see if we can do this without doing the whole flipping the fraction around, because that kind of confuses me. So if that confuses you too, let's try just expanding it out. 8 over 8 times 8 times 8. 1 8 on top, 4 8s on the bottom. How many pairs of 8s can we cancel out from the top and bottom?
One.
Only one, right? Because we only have 1 8 on the top. So here's our pairing. We'll cancel them out. Are we left with 0 on the top? No, what's our numerator going to be? 1. Awesome job. 1. And then how many 8s do we have on the bottom? 3 of them. So we can write 8 to the 3rd. And that's our answer. So, when you have a larger exponent in the denominator, it might help to just expand it out. It might actually be easier. Because if we wanted to use the quotient rule, this is what it would look like. 8 to the 1 minus 4. That's 8 to the negative 3rd. Got to put that over 1 and flip it around. 1 over 8 to the positive 3. Same exact answer, right? But we didn't have to do the whole flipping and putting it over one thing. So if you're really solid on that, awesome. Use the quotient rule, please. But if 2.1a is still a little confusing, you're more than welcome to expand it out, cancel your common factors, and then simplify your answer. I'm fine with that. 2 to the 4th over 2 to the 2. 2 to the 4 minus 2 gives us 2 to the 2. And that's 4 again. Just like in number 3. Whoops. Number 7, we got 5 to the 0 over 5 to the 3rd. Now again, we can use the quotient property if we want, but this numerator is interesting to me. What's 5 to the 0th power equal to? 1, right? So let's simplify our numerator to 1, and then we'll just keep our denominator the same. Besides actually solving 5 to the 3rd, is there anything else we can do with this fraction? 1 over 5 to the 3rd? I don't see anything we can do. That's just going to be our answer. We can skip that whole process by just recognizing, hey, anything to the 0th power is 1, so I'll just simplify that first. Again, the alternative is doing the quotient property or the quotient rule. 5 to the 0 minus 3 equals 5 to the negative 3. Put that over 1 and flip it so we can make our exponent positive. So 1, 2, 3 steps versus 1 step when we have a 0 exponent. Now this is where things started to get a little bit dicey because we're throwing in the negative numbers and people were getting confused. So definitely make sure you're paying attention to this section. 6 to the negative 4 on top, 6 squared on bottom. If we're going to use our quotient rule, we'll do negative 4 minus 2. Now I saw some people say this is 6 to the 2nd, 6 to the negative 2nd, 6 to the positive 6. But what's our actual final exponent here going to be? 6 to the negative 6th. Remember, if we start at negative 4, use your number line. I'll keep saying it. If you start at negative 4 and you're subtracting, you're moving to the left 2 spaces. So we start at negative 4. We're subtracting 1, 2 spaces, and we land at negative 6, right? So if the negative signs, the adding and subtracting confuses you, please just refer to the number line or even draw out your own little number line. And then if we make that positive, we're going to get 1 over 6 to the 6th, right? We don't want to leave that negative exponent in our answer. Number 9, I think about 80% got this wrong on the first try, which is perfectly fine. We're going to go over it. All these negative signs, especially with the quotient property, make it super confusing. So we've got -1 and -4. And in between those, are we going to have what? A plus or a minus right here?
Plus.
For right now, we have a minus. We'll get to the plus in a second. But because we're using the quotient property, we have to subtract. Now, what do two minus signs next to each other form? Two minus signs come together and form a
Plus.
positive, right? Thank you. Positive. So 3 to the -1 plus 4. So the most common mistake I saw was people recognizing that, hey, two minus signs form a positive, right? But then they wrote like 3 to the -1 plus -4. You guys see the mistake here with this?
Yeah.
Anyone see the mistake? What did I do wrong here? Jordan?
You didn't combine the two negatives.
Yeah, I did. They're right here in the plus.
Uh,
But then I didn't get rid of that negative, right? So you were actually correct. That's my bad. Yeah. We did not combine them because we left this negative sign on the 4. So we can't do that. When they come together, they form that plus sign. So there shouldn't be any more minus signs. 3 to the -1 plus 4 is 3 to the 3rd. Number 10, anything to the 0th power is equal to 1. So we can skip the quotient rule and just simplify 8 to the 0th. And then simplify our answer, because we don't need a 1 as our denominator, right? We already know that 1's our denominator. Questions on... Yes, sir. Yeah, go ahead. With number 11, we got an exponent of 1 up here. 6 to the 1 minus -3. Two minus signs form a plus. We get 6 to the 4th. So maybe you did a lot of these in your head, right? And you're going through these answers now and you're like, oh, I was way off. Like, how did I even get that? If you don't write out the work, it's a lot harder to try and remember what you did wrong. So I know a lot of this can be done in your head, but for your benefit, I highly suggest you write out the steps so that if you make a mistake, you can correct those steps as opposed to just writing down what the correct answer is. Because if you don't know how you got that answer, it's not helpful. Number 12, last one, 4 to the 4th minus -1 becomes 4 to the 4 plus 1, which is 4 to the 5th. Oops. There we go. Any questions on this worksheet? Show a thumbs. How are we feeling about the quotient rule? Thumbs up if you're feeling confident. Thumbs sideways if you could still use a little bit of help. And thumbs down if you're just not getting the quotient rule. Okay, good. I see a lot of thumbs up. That's awesome. Go ahead and get your notebooks out.